All right, welcome everyone. In this lesson, we're going to look at how to calculate the derivative of what we're going to call a basic function. So what are these basic functions going to be? Well, we're going to have a list of elementary forms. So these are just a list of functions that we should know the derivative of. So we'll have them memorized. And we'll see some of the rules for how to differentiate the combination of these functions. So what we get when we take these elementary functions and add them together, when we subtract them, or when we take a constant and multiply it with one of these elementary functions. So we're going to kind of develop these rules that allow us to calculate derivatives a little bit quicker than what we've seen so far. We've just looked at the limit definition of derivative. So going right back to the source of the definition there, and we've seen that calculating those limits, there's a lot involved there. And so we're going to start developing some of the differentiation rules that allow us to kind of calculate the derivative a little bit easier, a little bit quicker. All right, so let's start with two functions in particular. The function mx plus b and the function f of x equal to b, where m and b in each case here are constants. And kind of these two functions illustrate how the derivative really kind of gives us a way to measure the slope of a curve. So let's start with f of x equal to mx plus b. We want to calculate f prime, but let's think of f prime in the context of the slope of a curve. So here we have our function graphed, and we see that this is just a line with slope equal to m. And we know the slope is equal to m because if we go to our function here, mx plus b, this is just a function in y-intercept form. So m is the slope and b is the y-intercept. So we know what the slope of this line is. And at each point on this curve, or on this line, the slope is the same. So no matter where you go on this line, the slope is always going to be m. So the slope of our curve at any x value is equal to m for this one. So that means f prime of x is equal to m. F prime is measuring the slope of our curve at any x value. So if the slope of our curve at any x value is equal to m, well then that's what the derivative is. In the second one here, we have f of x equal to b, where again b is a constant. Now this is also a line, but it's a horizontal line. And because it's a horizontal line, the slope is always going to be 0. So remember, slope of a line, change in y over change in x. If the line is not going up or going down, then the change in y has to be 0. So for our horizontal line, the slope is just always going to be 0. And that's true no matter where you go on this curve. So if I were to pick any point along this curve, the slope of this line, the slope of the curve, would be 0 there. So at any x value, no matter where you go on this curve, the slope would be equal to 0. And so if the slope of the curve is always equal to 0, well then that means f prime of x is equal to 0. So we have these two kind of basic derivatives here, and we're going to look at how to extend this. But for f of x equal to mx plus b, the derivative f prime of x is equal to m, so it's just the number in front of x. And for f of x equal to b, where b is a constant, the derivative is just 0. And so this is kind of one we're going to, both of these we're going to be referring back to. So if we have a function that's just a constant function, constant by itself, the derivative is 0. And if we have this mx form here, the derivative is just the coefficient. The derivative is just the number in front of x. And we're seeing what happens really And we'll kind of investigate this further, but what happens to this b term? Well, when we differentiate that, it goes to 0. So there's the beginnings here of some of our different derivative rules, and that's what we're going to be investigating.